see here. Is that better? That's better. You guys might have put this together. You might have looked at the calendar, but this, what we're starting today is it as far as concepts for the whole rest of the year. Cool. We're going to spend 4 days on the solving of rational equations, and that'll be that. So hopefully we finish great. So just giving you answers there. We can go over any of the details of those if you'd like.
We got these right.
If you simplify that, that'd be 6.
3. Okay, you all have had a chance to look at some answers there. Do number 3 for sure. Thinking about what else you might want to do. All right, so let's focus in on number 3. I'm just reading here. Are you guys okay? You got the answers you need?
Actually, I need help for 2, actually.
Okay, that's cool. We definitely can do that. I'm going to erase all this stuff and kind of zoom in a little bit. Is that okay with you guys? Okay, so number 3. Okay, so I'm subtracting a couple of fractions here. And so whenever I'm subtracting fractions, I need to get a common denominator. And so I would say that the very amateur way of doing it is just to always multiply the 2 denominators together. That'll get you a common denominator, but it's probably going to create a big mess for you on the back end. So the only way to know for sure that you have the lowest common denominator is to see the individual factors making up the denominators. So it's imperative that we factor. So here's what that could look like. 5 over 2x, the 2 times the x, those are already prime. Those are already prime factors there, so we're not going to try to break those down any further. However, the other denominator can definitely be factored. Whenever you're going to factor, what should be the first factoring strategy that you use?
GCF.
GCF. All right, good. What's in common here? There's a 2 in common, and what else do they both have? Isn't that really crucial, right? Because when you notice that, you realize, whoa, the 2 matches the 2, the x matches the x. The leftovers here would be x plus 5. So I can now clearly see my factors. And on top of that, I can now clearly see what the left side needs. So the fraction on the left side needs a factor of x plus 5 in the denominator. That'll make it the same as the other denominator. But I can't do that unless I also multiply the top by the same thing. Okay, this will give me 5x plus 25. Oops. Over my common denominator. And now that I do have common denominators, I can combine. So I'd go ahead and do the subtraction. 5x minus x is 4x. There's nothing like the 25. I end up with this right here. And I am done. There is no further simplifying or combining of anything that I can do there, unless I wanted to distribute in the denominator, but I don't have to do that. What do you think, Colton?
Yeah, makes sense.
Was the factoring the difference?
Yeah.
Okay. Okay. Any follow-ups on 3? Okay, then number 2. Let's keep working at number 2. I know number 2 is not the easiest question, the easiest type of question, but I'm confident it's something you just haven't done yet. Let's just say that. You can definitely get there. Some of you have bought in. Listen, I have taught this for so many years. And I've tried, I think, all the ways. I mean, there might be some way I don't know about. But I've tried, like, so many different ways. I have arrived at this way because I think it's repeatable. I think it's helping you be a problem solver. So, Chase, we're doing 2.
Yeah.
Anytime you're faced with a paragraph in a math class, or really for that matter in an English class, you need to work on breaking it down into the important stuff that you need to pull out of it, right? Isn't that even true of like literature?
Yeah.
Like you'll read this whole page or paragraph in literature and you're just like, what was just said? I do not know. And then you break it down a little bit. You're like, whoa, okay, so this paragraph seems to be about, ooh, that sentence, wow, okay, that seems to be a focal point of this paragraph. You start to break it down, you figure it out. It's no different. It's no different. So the way that I break this down is I use a picture. So it says a cruise ship left Seattle, traveled towards Alaska, at an average speed of 18 kilometers per hour. I think, cool. Don't know much about this yet. Jaden, you going to survive? Is Stapler going to win? Stapler already win?
I got it.
Okay.
Literally have 6 staples and tape.
Anyways, it says a second ship left 2 hours later, traveled in the same direction but much faster, right? 25 kilometers per hour. Write and solve an equation to find how long it took for the second ship. Okay, now this is starting to make sense now. I'm starting to get some focus here as opposed to the start of it. I'm like, what is this even about? A couple of boats, Alaska, I don't know. How long will it take for the second ship to catch up to the first? I am going to draw a picture. Why on earth is the faster boat having to catch up to the slower boat? Say again? Who? Yeah, the slow boat left early. Okay, so we're going to say, here's how I usually draw my pictures. I'm going to say that that's Seattle right there, that starting line. The first boat, like you said, got a head start. He left early. And so there's going to be a little bit of space out there before the second boat even starts. So that represents my head start. There's the first boat there, a cruise ship. I'll just call this distance 1 for first boat. I know. How big of a head start? Well, I'm trying to get across here is that I'm definitely trying to make this really simple and understandable. Not like, whoa, let's go DCS for cruise ship. It's just the first boat. Keep it simple. How big of a head start did that first boat get? 18 times 2, right? 36. Okay, so 36 kilometers of a head start. They cheated, but whatever. Then the second boat, it's still in Seattle when that first boat is 36 kilometers out in the ocean, right? And then they go. Chase, you doing okay still?
Yeah, I was asking about like something that we did.
Okay. Okay, well, okay, fair enough. I just want to make sure that I'm not... I want to make sure I'm helping you. Am I helping you? Okay. So then the second boat finally takes off, and it's much faster than the first boat, so it will eventually catch up out there somewhere, we think. I'm going to call that distance 2. And so out here, this is that imaginary, they just caught up line somewhere out there in the ocean. Okay, so I'm hoping that you can and are willing to take the moment or two that it takes to draw the picture, because what we're going to do now is we're going to take this picture and try to write a relationship, aka an equation, that's really what I'm talking about, that involves all that stuff. The only requirement is that must be a true statement. You can't just make stuff up. So can I give you an example of something that's wrong, but somebody might write? Somebody could write this: D1 equals D2. How do we know that that's completely false? Because one boat, what did one boat do? It was different from the other boat. Got a head start. So isn't D1 clearly shorter than D2 the way that I've drawn it? So this can't be true. Here's another one. This one is even more devious. How about this? D1 plus D2 equals 36. This is just taking stuff and like sort of throwing it into an equation. And it's an equation, so that's a good start. But it's just not true. It's got to be true. So Coy, did you come up with a true relationship here?
Yes.
What'd you come up with?
25t equals 18t plus 36.
Okay, so you kind of jumped a little bit ahead of me. I'm going to go back one step. Would you guys be all right if I wrote D2 equals D1 plus 36?
Yeah.
Isn't that true? And I know sometimes in a math class we stumble over that word true. We're like, whoa, what do you mean it's got to be true? Like, it literally has to be the truth. It can't be just some made up thing with pluses and minuses and some numbers. It's got to express something that actually is true in real life. In our little real life boat scenario. Colton.
Would D2 minus D1 look equal 36?
Yes, that's just a slight rearrangement of what we have up there. Totally. That would work great. And that's why I don't say, and this is where I shy away from like the really rigid, you must make a graphic organizer. Like if you want to make a graphic organizer, cool. That's fine by me. Like that's probably not going to be the thing that makes you get it right or wrong. But if that does help you organize your thoughts, great. What's going to help you get it right or wrong is focusing on the truth, focusing on what's actually happening and trying to build the math from that versus I've got a method. I'm just saying draw a darn picture and then write something that's true. And if you do that, you'll be in pretty good shape. Okay, so then we get to Coy's idea. D2 would just be rate times time, so 25t. D1 would be 18t, as again it's rate times time. So now I just have to solve for t. To do that, I would subtract the 18t from both sides. So 7t equals 36. And then, of course, you guys are really good at solving stuff like that. So 36/7 of an hour would be the time that it would take. So that's what? Oh, that's a little over 5 hours. 5 hours and change. 5 1/7 of an hour.
5.14.
So, okay. I can buy it. That sounds good. Okay, Chase, a lot of discussion. You saw that?
Thank you.
Doing better than 5 minutes ago? Okay. All right. Anybody else? 1 or 4, I think it was. You doing okay with those? All right. Class starts at 05, right? I gotta check this. I can never remember. Class started, so we're out at 55. We're out at 55. You'd think I'd be able to keep track of this, but I can't. Okay, so all that being said, guys, we're gonna do just a couple of brief kind of warm-up-y exercise kind of things here together. And then we'll hit our concept quiz and we'll be done. Okay? So here we go. Just a little bit of review. We've solved questions like this in the past. I want to give you a little bit of a different take on this one. If you were to look at an equation like number 1 and identify the difficulties that you see, what jumps out to you like, whoa, I'm going to have to deal with this, I'm going to have to deal with that? The equal sign. What else jumps out to you? X's, variables, obviously. Yeah, different denominators. And let's back up a little bit. If there's denominators, there's fractions. Was anybody taken aback by the fact that there are fractions in this thing? We've done stuff like this. Is not impossible. We've done stuff kind of like this before. Let me propose this to you. If I could give you a way to make it go from something that has fractions to something that doesn't, would you go for that? Doesn't it make it easier? Okay. So a lot of the skills we've been working on are going to help you here. Your denominators are 9, 6, and 3. So what's the least common multiple of 9, 6, and 3? That's the greatest common factor. I'm looking for the least common multiple. 18, right? 9, 6, and 3, they all go into 18. I think 18 is the smallest number that they all go into. So this will be our kind of our first concept here. We're going to look for the least common multiple of all of the denominators, and that would be 18. So I'm going to show you, I want to show you a way to do this. Stand up, please. I'll show you a way to do this. It's a little bit different than some other years I've done this. I started doing this last year, and just based on feedback, I felt like students embraced this and enjoyed this and found this a little bit easier than some of the other methods that have been out there in the past, okay? So here's what I'm going to do. Recognize my least common multiple is 18. I'm going to get all my denominators to 18. I'm going to get them all to 18. So check it out. If I was going to take every fraction in here and get all the denominators to 18, what would I have to multiply the first fraction, the one on the left? What would I have to multiply that by? Yep. So I'm going to multiply times 2 and times 2. What would I have to multiply the second fraction by? 3. Yep. So it'd be times 3 times 3. And then the last one I have to multiply by 6. So is this making sense? Hey guys, come on in. Okay. So I'm going to now do the multiplication. So this would be 8x over 18 equals 3x over 18 plus 30 over 18. Still making sense? I got all my denominators to be the same. What's so cool about this is now in one shot, I'm going to be able to get rid of all the denominators. And let's remind ourselves of this. With an equation, whether it's got fractions or not, with an equation, whatever you mathematically do to one side, as long as you do it to the other side, it's okay, right? With very few exceptions. So here's what I'm going to do. I'm going to multiply every single term in my equation by 18. Am I not allowed to do that? So when I do that, do you guys see how the 18s would cancel on every single fraction? So what I'm essentially able to do is cancel all of these 18s with that 18, leaving me with something that's much easier looking. And if you compare, I would just propose, if you compare this with this, wouldn't you agree, the second red box looks a lot easier. Now, fully admit, there are other ways to do this. It is my opinion that the other ways are more complicated and introduce more and more fractions. My goal here is to go with fewer, aka no fractions, if I can. Okay, so I'm thinking that for you guys, solving this would be pretty easy. What would you propose? What would be my first step to finish this out? Subtract 3x from both sides. I agree. That gives me 5x equals 30. Dividing both sides by 5, I get a final answer of? Done. So once you get to this stage, I'm sure for all of you, it's going to be a pretty quick finish. Okay, questions? I'm going to leave you with one more, and tomorrow we'll be doing some more practicing with this. So if you would, flip ahead to our other question right here. And I don't know if we'll try this with a partner or not. I think we'll maybe process this one together. Do you see how it's similar? Okay, so if I'm going to look for that least common multiple, like I did previously, what would you guys say the least common multiple of all those denominators is? 4x, right? The least common multiple of 2 and 4 is 4. There's a couple of x's in there, so I would say 4x for my least common multiple. All right, so if I'm going to do this, get to that common denominator, what do I need to multiply the first fraction by?
4.
Yep, multiply the top by 4, multiply the bottom by 4. Technically, I'm multiplying by 1, right? But it's 4 over 4. Second fraction, what do I need to multiply by? I need the 4 to become a 4x, so I need to multiply by x, don't I? So times x times x. And then that final fraction is a denominator of 2x, so I need to multiply by
4, or 2.
2, right? 2 times 2 to get to 4. So times 2 times 2. All right, once I've done that, I can write it out as 8 over 4x plus x over 4x equals 10 over 4x. So at this stage, I've got a nice, lovely common denominator on all of them. And remember, once I've done that, this is the step where I get to get rid of all the denominators. What would I need to multiply by to get rid of them?
4x.
4x. Yep, that's going to cancel them out. So if I multiply everything through by 4x, all of these denominators will cancel with that 4x, leaving me with 8. Oh my goodness, look at how easy that looks. 8 plus x equals 10. The answer for x, the solution would be 2. So I'm hoping you see the value in getting that common denominator, because then you can eliminate denominators, and then for you guys, the rest will be like this one, really easy. Whereas before, I mean, seriously, compare this to that. There's no comparison. You can eliminate those denominators, it gets easy for you.
Why wouldn't you multiply like the top, you multiply by 4 times 2.
Yep.
Why wouldn't you do 4x times 2?
So we're looking to get this least common multiple of 4x. This already had an x. So if I were to multiply by 4x,
Oh, you just make it to whatever, yeah. Okay.
multiply by whatever you need to get it to what you want. And if it's already got one or more of the elements of what you want, you don't need to multiply by those. Otherwise you'll have extras.
Yeah.
Cool. Okay, let's go ahead and get the tables flipped